Now I will be discussing my part in AJ 104 Lesson 6. Number 1. Distinguish between the cis and trans isomers. So, cis isomers are molecules having the same connectivity of atoms and are composed of identical side groups that can be found on the same sides. So, the cis isomer can be found um, on the same sides. So we have identical side groups here, whilst trans isomers are that can be found on the opposite sides. So this is trans isomer. Number 2. Explain the requirement for cis-trans isomerism in alkenes. So the requirement to have a cis-trans isomerism in alkenes is that compounds that have one of their carbon bonded to two identical groups can't exist as cis-trans isomers. Only when both carbons are bonded to two different groups are cis-trans isomers possible. AJ 104, Lesson 6 Learning Activity. Number 3. Give examples of a cis isomer alkene, then demonstrate how they are named. So, this is my 3 examples of a cis isomer alkene. Letter A. So, this carbon double bonded to carbon, and we have the attachment of two hydrogens and two chlorines. So, this is named as cis 1,2 dichloroethene. We have the double bond here that indicates the restriction of the rotation. So cis means on the same sides. So we have the same, on the same side we have chlorine, and here we have hydrogen. Letter B, we have methyl and methyl, hydrogen and hydrogen. So this is named as cis-butene. Letter C, CH3, CH3, and HH, hydrogen. So this is named as cis-hep3-ene. Number 4. Give 3 examples of a trans isomer alkene, then demonstrate how they are named. So here we are going to demonstrate trans isomer alkene. We have carbon double bonded to carbon, chlorine, hydrogen, hydrogen, and chlorine. So this is named as trans 1,2 dichloroethene. So trans meaning on the opposite sides. So we have an opposite here, chlorine. So same with the letter B, trans-butene. So we also have on the opposite side we have methyl, CH3, CH3. Then letter C, we have CH2CH3, CH2CH3. So this is named as trans-hep3-ene.
Lesson 6 distinguish between the CIEs and trans isomers. So when we talk about the difference between CIEs and trans isomers, one of the main difference is in the arrangement atoms in a double bond. However, we will talk at some other key differences between the two below. This my answer. These are some differences between CIEs and trans isomers. To know more about isomers and other chemistry, double bond and the two atoms bonded to each carbon atoms lies in the double.
So, this is the learning activity lesson 6 month, and my part of this learning activity is part 3 and 4. Now I will be first discussing the number 3. So, Number 3. Give 3 examples of a cis or cis isomer alkene, then demonstrate how they are named. So it says that 3 examples of cis isomer. So first, this is our example. So it's said that an cis trans isomer alkene should be um, a double band because rotation should not be exist at all. So that's why um, there is a double band found because it is stated in the two rules or two requirements for cis trans isomerism. It said that first is rotation must be restricted in the molecule. So here is it, ma'am. And then the next rule is there must be two non-identical groups on each double bonded carbon atom. So this 1, 2 hyphen dichloroethene is a size isomerism because there is a bond, so rotation is restricted, and then there is two unidentical groups found, and also here two non-identical. So it is cis or cis because it said that cis means on this side. So side and then side. That would be all in our first example in number 3, ma'am. So here is our second example in number 3. Sorry, ma'am. Sorry. So here is our second example in number 3. So this is but2ene because this is the new naming system as your course pack stated now. And as usual, there is a double band because this is to prevent or to restrict rotation. And then the rule number 2 is two non-identical groups, ma'am, which is found here and then here. Also, ma'am, this is an cis isomer alkene because the groups or the element here is in this side, ma'am, because that is the meaning of cis in Latin, in this side of. So that would be all, ma'am, for our second example. So this is our last example for number 3, ma'am. So this is cis het 3Ne again, ma'am. This is the new naming system, ma'am, from your course pack given, ma'am. So this is our 3 example. As usual again, ma'am, the 2 carbon, double banded carbon to prevent or to restrict rotation. And then the rule number 2, the 2 non-identical groups, and then the formula that is on this side, ma'am. They are same that on this side. So that's why we classify or we take it as an example of cis isomer alkene, ma'am. And this is from heptane, the parent name, but the example, but the given is alkene, so we change it to the suffix ene. So this is our third example of cis isomer alkene, ma'am. So this will be all for the number 3. Here is my next part of the learning activity map, the number 4. So I will read the question. Give 3 examples of trans-isomer alkene, then demonstrate how they are named. So ma'am, before proceeding, ma'am, our answer in number 4, ma'am, is connected to number 3. However, the groups are just opposite. So ma'am, I will start explaining our first example in number 4. So our first example is called trans-1, 2 dichloroethene. So it is ENE because it is alkene. It is ethane, and then we change it to ethene because the given is alkene. So we change the suffix. So ma'am, see double bond of the carbon. This is to prevent the rotation or to restrict the rotation. And then in the number 3, the given there is the on this side, the chlorine is here and the hydrogen is here. However, in the trans-isomer alkene, it says that trans means in Latin is across or the other side. So that's why, ma'am, our example is changed into this. So our chlorine is in the down part, and then the hydrogen is in the upper side, ma'am. So it is our example in trans isomer alkene, ma'am. But it is still an cis trans isomer alkene, ma'am, because the groups here is still non-identical. However, just the position of them is different from cis isomer alkene. That would be all, ma'am. This is our second example in number 4, ma'am. So this is trans-but 2 ene. So this is connected to example of number 3, letter B. But the example in letter B in number 3 is just cis, but here is trans because it is the problem stated here in number 4, ma'am. So as usual, ma'am, the number 3, the carbon is double bond just to prevent the rotation. And then that is rule number 1. And then the second rule is 2 non-identical groups, ma'am, which is found here. It is still non-identical group, so it is considered an cis trans isomer alkene. However, it is trans, ma'am, because the formula, ma'am, here is across, ma'am, as what the meaning of trans in Latin, cross or on the other side. It is different from cis isomer alkene, ma'am. So we classify or we take it as an example of trans isomer alkene. So ENE, ma'am, it came from the parent name butane, but we changed it to suffix ENE because it is an alkene. So that would be all, ma'am, for our second example. This is our last example for trans isomer alkene. So this is called trans-hept -3 ene. So it came from the parent name heptane. This is the suffix ene because the a and e is changed into this because it is an alkene, ma'am, because it is the stated in the problem. And then this is the new naming system, ma'am, as stated in your course pack given in lesson 6, ma'am. And then, as usual, ma'am, the carbon here is double banded just to prevent the rotation, which is the number 1 rule in cis trans isomer alkene. And then the groups, ma'am, is unidentical or they're not the same. And as the formula, ma'am, the given here is across or it is on the other side, which is the definition of trans in Latin, that it is an across or on the other side, unlike in the cis isomer alkene that they are saying on the side here. But in trans, it is on the opposite side or the across side. So, ma'am, that would be our examples in 3 and 4 in cis isomer alkene and trans isomer alkene.